Hello, you are welcome. My name is Dr. Kingsley. This is Best Brain Academy. I hope you are enjoying your day. Now, in my class today, I'm going to be continuing on stoichiometry. The aspect of stoichiometry I want to continue on today is mole and the Avogadro's number. Mole and Avogadro's number. That is to say, what is the relationship between 1 mole of a substance and the Avogadro's number. Now, we know that 1 mole of a substance, is equals to the molar mass of the substance. 1 mole of a substance is equals to the molar mass of the substance. Also, 1 mole of a substance is equals to the Avogadro's number of particles. 1 mole of a substance is equals to the Avogadro's number of particles. Now, the Avogadro's number of particles, according to the Italian scientist Avogadro, he estimated that 1 mole of a substance contains 6.022 times 10 raised to power 23 particles. Okay, particles. 1 mole of any substance will contain 6.022 times 10 raised to power 23 particles. Remember, particle can either be atom, it can be ion, or it can be molecule. It can be molecule. It can be what? Atom, it can be ion, it can be molecule. It can be electron. It can be electron. And so on and so forth. Now, we know that what? That 1 dozen of egg contains 12 eggs. We also know that 1 score of egg contains 20 eggs. Now, the same way, 1 mole of any substance, if you permit me, 1 mole of egg will contain 6.022 times 10 raised to power 23 eggs. Okay, 1 mole of any substance will contain this number, okay, of particles. Now, if 1 mole of a substance is equal to molar mass, and 1 mole of a substance is also equal to Avogadro's number, which is this, it simply means that what? Molar mass of substances, which is 1 mole, is equals to what? 6.022 times 10 raised to power 23, okay, particles. That is what it simply means. If this is equal and this is equal to this, then all of them are what? Are equal. That is the molar mass of any substance is equal to 1 mole of that substance. And that is also equal to the what? The Avogadro's number of what? Of particles. So please, remember this. If you know the relationship, you can be asked to convert from mole to molar mass, or from molar mass to what? To the number of particles, which is number of entities. Now we can take one of such. So let us take a question. Let's say we have find the number of moles, in 12 grams of calcium. Find the number of moles, or find the number of atoms. Find the number of atoms in 12 grams of what? Of calcium. Now, when you see this kind of question, you remember the relationship that what I gave you. The relationship is that what? 1 mole of a substance is equal to the molar mass of that substance, which is equal to Avogadro's number. So what it simply means is what? 1 mole of calcium is equals to molar mass of calcium, which is equal to what? Avogadro's number. Avogadro's number. What does this mean? It simply means that what? That this and this are equal. So molar mass of calcium, the molar mass of calcium is equal to what? The Avogadro's number of particles. This is Avogadro's number. Now, what is the molar mass of calcium? From the periodic table, you can get the molar mass of calcium. Now, the molar mass of calcium is 40 gram from the periodic table. So, 40 gram of calcium will always contain the Avogadro's what? Number of particles. What is Avogadro's number? Avogadro's number is 6.022 times 10 raised to power 23 atoms. The particles we are talking about now is atom, because they say find the number of what? Atoms. So molar mass of calcium contains Avogadro's number, and molar mass of calcium is 40 gram of calcium, and you contain what? 6.022 times 10 raised to power 23 atoms of what? Of calcium. Now you can now relate this with what? The equation they gave you. The equation they gave you is what? How many atoms will be in 12 what? Gram. Since you have known that 40 gram we have this number of atoms, therefore the 12 gram of calcium from the equation, how many atoms will it what? Will it give you? You can take it to the what? X. The molar mass 40 gram gave us this number of atoms. 12 gram they are demanding from us. How many will it give us? Take it to the X. You can now see that X will become, okay, 12 gram times this, which is 12 gram times 6.022 times 10 raised to power what? 23 atoms. Okay, now divided by what? Divided by 40 gram. I just made X the subject of formula. This multiplied by this, okay, divided by 40. So gram will cancel gram. So when you do this multiplication, you will get the answer to be 1.81 times 10 raised to power 23 atoms. So what it simply means is what? 12 grams of calcium will contain this number of what? Atoms. Since 1 mole contains this. So that is the answer to that question. So let us look at question 2. Question number 2 says find the number of atoms of oxygen present in 18 grams of oxygen. Find the number of atoms of oxygen. Now, if you are looking for the number of atoms of oxygen, remember that oxygen exists as a molecule. And if oxygen exists as a molecule, you should know that the molar mass of oxygen is the molecular mass, okay, which is 32 gram. That is 32 gram per mole. That will be the molar mass. The molar mass of oxygen, which is 32 gram, is the molecular mass, because oxygen exists as a molecule, which is what? 16 atomic mass, 16 times 2. Now listen, because oxygen exists as a molecule, if you are looking for the number of atoms present in a given mass of oxygen, the number of atoms, you will not use the molecular mass. Assuming they ask you to find the number of molecules, you will use the molecular mass. But when they say find the number of atoms, use what? The atomic mass to equate the what? The Avogadro's number. But when they say find the number of molecules of oxygen, then you use the molecular mass to equate the Avogadro's number. If you understand this very well, you will not have what? Mistakes, okay, in this. Where is my this is? So if you want to solve this now, what it simply means is that we will be taking this atomic mass of oxygen is equals to Avogadro's number of atom. Is equals to Avogadro's number of atom. So you can now see atomic mass. We go with what? Atom. So what is the atomic mass of oxygen? The atomic mass of oxygen is 16 gram. So 16 gram of oxygen will give you 6.022 times 10 raised to power 23 atoms of oxygen. Okay? So if 16 gram of oxygen will give you this number of atoms of oxygen, then the equation will now become 18 gram. How many atoms will it give you? 16 gram, which is the atomic mass, gives us Avogadro's number of atoms. From the question, 18 grams of oxygen. How many will it give us? How many atoms? Take the number of atoms to the x. It simply means that what? Our x, if we cross multiply, will become 18 times 6.022 times 10 raised to power 23. Okay, divided by what? Divided by 16. So our answer will become 6.8 times 10 raised to power 23 atoms, okay, of oxygen. That is the answer. So we'll come to question 3. If you look at this question 3 and look at question 2 that we have solved, you will think that they are exactly the same thing. The difference is that they say we should find the number of what? Molecules. Number of molecules in 16 gram of oxygen. While the other one is find the number of atoms. The same 16 gram of oxygen. But when they say find the number of atoms, we use the atomic mass to equate the Avogadro's number of atoms. Now, because they say we should find the number of molecules, what we are going to use to equate the Avogadro's number is what? You are going to use the molecular mass, because oxygen exists as a molecule. So what you do is what? Molecular mass of oxygen, okay, will give you 6.022 times 10 raised to power 23 molecules of oxygen. So can you see now? Molecular mass goes with this number of molecules. Assuming it is atomic mass, it will go with this number of what? Atom. So having known this, molecular mass of oxygen is equal to 6.022 times 10 raised to power 23 molecules of oxygen. But what is the molecular mass of oxygen? Oxygen exists as a molecule, O2. So the molecular mass will be the atomic mass, which is only one. Atomic mass, 16. Then multiply by the number of molecules, which is what? 32. So it simply means that the molecular mass of oxygen is actually what? 32. 32 gram per mole. So this will be what? 32 gram of oxygen. Okay? Will give us what? 6.022 times 10 raised to power 23 molecules of oxygen. So if the molecular mass, which is 32 gram, gives this number of molecules, then the mass they gave you in the equation, which is 16 gram of oxygen, what will it give you? So you don't know, so you take it to be what? To be x. So what it means that x becomes equals to 16 gram multiplied by 6.022 times 10 raised to power 23 molecules. Okay, then divided by what? By 32. Divided by 32 gram. Of course, gram will cancel gram. So that when you multiply out, you will be having 3.011 times 10 raised to power 23 molecules of oxygen. So that is the answer.